Aggregate materials have many uses in highway construction. Dense graded aggregate is used as a base material to provide stability, strength, and drainage. Open graded aggregate, sometimes called clean stone, is the major component of asphalt and concrete mixtures. Clean, well-graded sand is also an important aggregate material used in the production of these materials. A well-constructed highway project begins with good materials. Good stockpiling practices are an important part of quality control for all aggregate materials. From the mining operation to the final product, one of the most important factors used to determine the quality of an aggregate is gradation. The gradation of an aggregate tells us the amounts of the material that are of a particular size. In the production process, stone is crushed, screened, washed, and blended until it is at the proper gradation. Aggregate production revolves around getting the material to the gradation that meets specifications. Maintaining proper gradation is essential for quality control of the construction materials that will be made from them. Before we concentrate on quality control at the stockpile, let's take a look at what goes into the making of the various aggregate products we'll be working with. The production of aggregate materials is comprised of 6 basic processes which are performed using various methods and equipment depending upon the many variations in which aggregate deposits are found. The basic processes are stripping, drilling and blasting, loading and hauling, primary, secondary, and tertiary crushing and screening, stockpiling, and finally, load out. The first task in the production of aggregate is uncovering the deposit to be mined. Stripping is the process of excavating the overburden from the deposit. The overburden may be composed of many types of soil, organic material, or unconsolidated rock, and can be removed using various types of earth-moving equipment. It is then transported to a designated area called a spoil pile and deposited in a manner that is environmentally safe and aesthetically pleasing. Occasionally, the overburden is used as fill material on construction projects. For hard rock deposits, drilling and blasting is a necessity. The purpose of drilling and blasting is to achieve the initial fragmentation of the stone deposit. The blast holes are drilled in a pre-calculated pattern depending upon the type of deposit, drill hole diameter, and the hole depth. The spacing between the holes is scientifically calculated in order to ensure maximum fragmentation of the rock while minimizing ground vibration and noise. After drilling has been completed, the holes are then loaded with explosives and blasting caps. The caps are designed so that all the explosives are not detonated simultaneously. They have built-in delays to facilitate timing a blast to reduce ground vibration and noise. Once the explosives have been prepared and loaded, the blast shot is ready to be activated.
3, 2, 1, fire in the hole.
Fragmented stone, called shot rock, is now ready for loading and hauling to the primary crusher. The next step in the production of aggregate material is transporting the shot rock from the face of the quarry to the primary crusher. This process involves the largest pieces of equipment used in quarrying operations. Front-end loaders and hydraulic shovels are used to load stone from the shot or muck pile into off-road haul trucks for transporting the fragmented stone to the primary crusher. The front-end loader is a highly versatile piece of equipment. While its digging ability is not as great as a shovel, its mobility adds efficiency in particular applications. Haul trucks range in size from 25 to 50 tons. This weight relates to its payload capacity. The primary purpose of these units is to carry shot rock from the muck pile to the primary crusher. As these trucks reach the primary crushing facility, the stone is dumped into a hopper located over the primary crusher. This is the first stage in the crushing and screening process. In most instances, shot rock is moved from the primary loading hopper to the primary crusher by means of a vibrating feeder. The two types of primary crushers most commonly used are the jaw crusher and the gyratory crusher. A jaw crusher, as the name implies, utilizes a movable jaw, sometimes called a swing jaw, to crush shot rock against the stationary jaw. With a gyratory crusher, shot rock falls into the bowl. It is crushed by the eccentric motion of the crushing head. The purpose of the primary crusher is to reduce the shot rock to a size that is easily and safely transported upon belt conveyors to the secondary crushing and screening stage. Before the stone reaches the secondary crusher, it is fed onto a vibrating screen, often referred to as a scalping screen. The function of this screen is to separate large pieces from ones that are typically smaller than 2.5 inches, and then route the larger pieces through the secondary crusher. All material larger than 2.5 inches is either scalped off as riprap or is fed to the secondary crusher for further size reduction. Stone leaving the secondary crushing and screening stage may be conveyed to another sizing screen. The primary function of this screen is to remove everything typically passing a 1.5 inch opening. This material is crusher run and generally represents 30 to 50% of total production. Material larger than 1.5 inches is called surge stone. It is either conveyed to a surge pile or is fed directly to the tertiary circuit. In most cases, the tertiary circuit represents the final crushing, screening, and sizing of aggregate products. It is during this stage of the operation that the material is sized and separated into various coarse and fine aggregate products. These materials are generally referred to as clean stone or coarse aggregate sizes. Coarse aggregate sizes number 57 or number 8 and fine aggregate size number 10 and gradings A and B sand are examples of such products. Sometimes, in order to meet specifications, clean stone products must be washed to remove dust. This is normally done on another vibrating screen which sprays pressurized water on the stone as it moves down the screen deck. For sand and gravel operations, the next step after stripping is loading and hauling the material to the raw feed hopper. Because of the loose nature in which these deposits are found, it is not necessary to drill and blast. Hydraulic backhoes and shovels are commonly used to load sand and gravel from the pit face into off-road haul trucks for transporting to the surge pile. At some operations, material may be dumped directly into the feed hopper. However, at this plant, the raw feed is being placed on the surge pile. This is done to ensure a steady feed to the plant and to allow the plant to continue to run when the pit is not in operation. A front-end loader is used to charge the feed hopper. A vibrating feeder is used to move material onto the conveyor belt, which transports it to the barrel screen. Here, water pressure and the turning action of the screen are used to separate the sand and gravel. Oversized gravel is taken to a crusher just as in a stone plant for primary crushing. Gravel products are sized over a screen deck and are conveyed to separate stockpiles. The most common sizes are number 57, number 68, number 7, number 78, and number 8 gravel. The fine aggregate from the barrel screen is collected in a sand sump and pumped to the top of the plant for sizing. Various types of water classifiers are used to separate the fine aggregates into the proper sand grades. Standard products, such as grading A concrete and masonry sand, are conveyed to the stockpiles. This plant also makes several specialty products, such as golf course bunker and greens mix sands and filter sand. As we've just seen, a lot of effort goes into crushing, screening, washing, and blending the various aggregate materials to the proper gradation. Once the finished products have been sized, the material must be stored until ready for use on a construction project. This is done so by using either trucks or conveyor belts to stockpile material on a clean, level surface. In many cases, the aggregate must be moved from the stockpile at the quarry to another stockpile location, such as an asphalt or concrete plant. Handling aggregates properly during storage and then later for loading and shipment is critical to maintaining the quality of the product. Good stockpiling technique is important at the plant, job, or any other materials storage site. The first thing that must be done in constructing a proper stockpile is to select a good location. The area should be thoroughly cleaned with no foreign material left behind to contaminate the aggregate. The area should be graded relatively smooth so that water will drain. If possible, a distinctly different and smaller size aggregate should be used for a layer at the base of the stockpile. This area has been cleared and graded for a new stockpile. Crusher run is being placed on the ground to separate the pile from the ground. This will keep the water out and prevent any contamination from the ground. Once a suitable location has been prepared, the stockpile is ready to be built. Proper construction is critical to maintaining the gradation of the aggregate product. Poor stockpiling practices can cause crushing of the aggregate pieces. If the gradation is changed either by crushing or segregation during handling, the product may not meet specifications, nor will it have the desired construction properties. Let's look at examples of good and bad techniques for stockpiling aggregate products. Material segregation is one of the primary things to avoid when constructing a stockpile. Segregation occurs when the larger particles separate from the smaller ones. The result is coarse and fine areas within the stockpile. Because the material is no longer properly blended, it is not a desirable construction product. The most common cause of segregation is the larger particles separating in a fall or by rolling down the side of a pile. To prevent this from happening, make sure the aggregate does not fall or roll any more than it absolutely must. This is an example of good technique. Note how the trucks unload into side-by-side piles. Then the loader is used to mix the small piles, blending the aggregate. This helps prevent or minimize segregation. Notice that the loader bucket is above ground level as it enters the pile. This is good practice. The operator here is driving too far up on the pile, a practice which could crush the material. The wheels should instead be kept on the ground. Some forethought in pile placement will prevent the equipment from crushing the material. Another situation to avoid is running the loader on top of the pile. The stone will be crushed. Clean stone that's not supposed to contain fine material will become contaminated. Trucks backing up on a crusher run pile are not as harmful as a track vehicle. When possible, use rubber-tired vehicles to blend the pile. This is another example of poor technique. Pushing material over the edge of a pile can promote unwanted segregation. Dumping in staggered piles at the base of a large stockpile is best for blending purposes. However, at some locations, space limitations do not allow for this method of stockpiling. No matter how the stockpile is constructed, have the material dumped and blended so that it always falls as short a distance as possible. Not following this guideline can cause segregation. When stockpiling with a conveyor stacker, it is important to make sure the material coming off the conveyor does not fall too far or down the side of the pile. Remember, the greater the fall, the greater the segregation. To minimize segregation that does occur in the fall, the pile should be blended by a loader. The material from this conveyor is falling too far, segregating the material. The larger particles are rolling to the bottom of the pile. This conveyor is equipped with a device that minimizes segregation. The turning action of these plates blends the material as it comes off the conveyor. This limits the free fall of the larger particles. At this plant, the stockpile is on a clean and level surface, and different aggregate products are well separated. At this plant, the stockpile is not as well maintained. You can see in this level that the product has been crushed. Attention to the details of handling aggregate material should result in a product that is clean, not segregated, and meets specifications. Keep in mind that changes in the quarrying operation can cause a detrimental change to the final product. All workers should keep a close watch for any changes in the aggregate material. One of the most obvious changes is an alteration in product color. Workers should also watch for any sign of coating or other contamination. It's important to catch this before an entire stockpile is contaminated. Before the product is ready for final delivery, it must be inspected. Both producers and VDOT personnel will sample and test the gradation of the aggregate in a stockpile to ensure that it represents the material stored there. The Materials Division Manual of Instructions describes 3 methods of obtaining samples from stockpiles. The first is general stockpile sampling. This method may be used at the asphalt plant for proportioning the various aggregates that go into the mix. The area to be sampled is opened up to expose the interior material. This may be accomplished by slicing the face of the pile with a front-end loader or a shovel. Next, the inspector uses a square-end shovel, which is inserted nearly perpendicular to the face of the exposed material, full depth of the shovel, and raised vertically to prevent segregation. At least 6 shovelfuls are required. They should be taken at equal spacing across the pile at third points of the height of the stockpile. This sampling method works best with finer materials. The most commonly used sampling method is miniature stockpile sampling. A loader operator builds a miniature stockpile by digging into the pile and pulling out material to make a smaller pile. After the loader mixes the miniature stockpile, it should be back-dragged. Samples are taken at 3 randomly selected points within the top of the miniature stockpile. A third sampling method involves the use of a sampling tube. This method is used for sampling aggregate sizes smaller than number 10 size and all fine aggregates. The sampling tube must be at least 2 inches in diameter and 3 feet in length. Samples are obtained at 5 different locations in the stockpile. The importance of sampling is equivalent to the importance of good quality control. The primary concern of sampling is to take the samples that will represent the stockpile as closely as possible. If the stockpile does not meet the specifications, it cannot be shipped. Although the bulk of this video pertains to stockpiling and handling at aggregate production facilities, a lot of the same principles would apply to stockpiling and handling aggregates at end-user sites. Proper stockpiling and handling procedures are equally important at hydraulic cement concrete and asphalt concrete production facilities. At these 2 types of end-user facilities, various amounts of stockpiling and handling of aggregate takes place. The same principles apply to staging areas. A good example is at the asphalt plant. Aggregate stockpiled at the plant is loaded into bins where it is conveyed into the plant for asphalt production. In order for the asphalt concrete to meet specifications, the aggregate going into the plant must be clean and well blended. Whether at an end-user's production site or at a staging area, it is critical that proper stockpiling and handling techniques are adhered to maintain the quality of the product. Proper handling during loading is just as important as during stockpiling. Poor loading techniques can result in a segregated or damaged material. Various finished products, including riprap, coarse and fine aggregates, sand, and pug-milled materials are loaded into trucks or tractor trailers. This is done with front-end loaders or directly from storage bins. When using a loader, the operator should keep the bucket above the base level of the pile and avoid removing material within 1 foot of the ground surface. Using the very bottom of a pile may result in contaminated aggregate. Try to minimize the distance the material will have to drop. This will help prevent both segregation and breakage of the material. In some cases, trucks are loaded directly from storage bins. In these situations, it is important to avoid letting the bin run empty. The higher the level of material maintained in the bin, the less distance the material will fall. Following this guideline will minimize segregation and breakage. If you can, load trucks in a series of drops. The aggregate won't fall or be able to roll as far. At this plant, the truck drivers load their own trucks from the bin. This driver is doing a good job of loading in a series of drops. At some plants, material is shipped by rail. Here, the locomotive operator is doing a good job of moving the cars along so the material doesn't fall too far. The sand and gravel plant we saw earlier ships much of their material by barge. It's clear that this barge was loaded in a series of drops. Base materials are typically processed through a pug mill. A pug mill operation provides for consistent blending of the material, as well as provides the opportunity to add additional materials for proper gradation. Water can also be added to the base material through the pug mill to obtain optimum moisture for compaction purposes. At some pug mill operations, a cement silo is added to the system in order to produce cement-stabilized aggregate base material. Although pug milling blends the material, the same precautions must be used to prevent delivering a segregated, contaminated, or damaged aggregate to the pug mill. The drop from a conveyor could cause the material to segregate. Don't have the conveyor drop the material directly into the pug mill feeder. This dozer is pushing material into the feeder, mixing as it goes. Pushing and mixing the material assures that a more consistent product is fed into the pug mill. There should be a separate feeder for each component aggregate size used to produce base or sub-base materials. Here, water is added and mixed to obtain optimum moisture. Pug milled material should be loaded with the same precautions as materials straight from the stockpile. Loader operators are the last to handle the aggregate. They must give particular attention to assuring that trucks are loaded properly. Loader operators are also a key player in the quality control of the material. While loading, they should watch for oversized material, segregation, and contamination. They should make sure the loader bucket, truck bed, or rail car being loaded is clean. Once the trucks have been loaded, they proceed to the truck scales where certified bonded weigh personnel weigh and dispatch the trucks to the proper job location. Everyone involved in the handling of aggregates, from the aggregate producer to the contractor, must make sure that it is done properly. Quality control at all points of an aggregate operation is essential to the final product that will not only meet specifications, but is a quality construction product. Preventing segregation and following good stockpiling and handling techniques will produce quality materials for use in all aspects of highway construction.